Welcome to Future Unveiled. Today, we're diving into what may be the most transformative technological shift of our generation, the emergence of truly integrated multimodal artificial intelligence. Not the simple combination of text and images we see today, but a fundamental convergence of perception, reasoning, and action that will reshape every aspect of human civilization within the next 15 years. We stand at an inflection point. The artificial intelligence systems of 2024 and early 2025 have shown us glimpses of what's possible when machines can simultaneously process vision, language, audio, and even basic spatial reasoning. GPT-4v can analyze images while maintaining conversational context. Google's Gemini processes video streams in real time. Meta's latest research demonstrates AI that can reason about three-dimensional spaces, but these are merely the opening notes of a symphony that will crescendo into something far more profound. The scientific community is converging on a singular realization. The future of AI isn't about making individual modalities more powerful. It's about creating systems that think the way humans do, integrating multiple streams of sensory information into coherent understanding and action. This isn't just technological evolution, it's the birth of artificial cognition that mirrors biological intelligence. Let me take you through the current state of the art, where we see the foundation being laid for this revolution. The breakthrough architectures emerging from research labs today aren't simply scaling up existing models. They're fundamentally reimagining how artificial systems process reality. The transformer architecture that gave us ChatGPT and its contemporaries was revolutionary for language, but the multimodal transformers of 2025 are already demonstrating something unprecedented: the ability to reason across sensory boundaries. When DeepMind's latest models process a video of someone cooking, they don't just identify objects and actions. They understand the causal relationships, the temporal sequences, the implicit goals, and can predict outcomes. They're beginning to construct what cognitive scientists call mental models of reality. Recent benchmarks published in Nature Machine Intelligence show these systems achieving performance levels that seemed impossible just 2 years ago. On complex visual reasoning tasks that require understanding physics, social dynamics, and temporal causality, the best multimodal models now score above the 75th percentile of human performance. More remarkably, they're doing this across languages and cultural contexts, suggesting they're learning something fundamental about how the world works rather than merely memorizing patterns. But here's where it gets truly fascinating. The latest research from MIT, Stanford, and leading industry labs suggests we're approaching what researchers call the embodiment threshold. This is the point where AI systems don't just process multimodal information, they begin to understand it through the lens of potential action. They're developing what roboticists call affordance perception, the ability to look at the world and immediately understand what can be done with it. The implications are staggering. We're not just talking about smarter chatbots or better image recognition. We're talking about AI systems that can observe, understand, plan, and act in the physical world with human-level sophistication. The embodied AI research emerging from robotics labs worldwide is converging with multimodal language models to create something unprecedented. Artificial intelligence that exists not just in digital spaces, but as active agents in our physical reality. Consider the technological convergence happening right now. Brain-computer interfaces are achieving unprecedented fidelity, with Neuralink and competing technologies demonstrating direct neural communication. Quantum computing is moving from laboratory curiosity to practical acceleration of AI training. Edge computing is bringing sophisticated AI processing to every device. When these technologies converge with multimodal AI over the next decade, we'll witness a transformation in human-machine interaction that makes the smartphone revolution look incremental. The robotics industry is already anticipating this convergence. Boston Dynamics' latest platforms aren't just mechanically sophisticated, they're designed as embodiment platforms for multimodal AI, Tesla's Optimus program explicitly aims to create general-purpose humanoid robots powered by the same AI architectures that drive their vehicles. But this is just the beginning. By 2030, we'll see AI systems that can observe human behavior, understand complex instructions given through gesture and speech, and execute multi-step tasks in unstructured environments. The education sector will be among the first to experience this transformation. Imagine AI tutors that don't just answer questions, but observe student behavior, recognize confusion or engagement through facial expressions and body language, adapt their teaching style in real time, and provide personalized instruction that responds to visual, auditory, and contextual cues. These systems won't replace human teachers, but they'll augment human education in ways that could democratize access to world-class instruction, regardless of geographic or economic barriers. Healthcare represents perhaps the most profound opportunity. Multimodal AI systems are already demonstrating the ability to diagnose conditions by analyzing medical images, patient speech patterns, and behavioral indicators simultaneously. By 2030, we anticipate AI systems that can conduct preliminary medical assessments by observing patient movement, listening to speech patterns, analyzing skin coloration, and integrating this with reported symptoms and medical history. The potential for early detection of neurological conditions, mental health issues, and systemic diseases could revolutionize preventive medicine. But let's examine the timeline more precisely. The research trajectory suggests several key breakthrough moments approaching within the next 15 years. By 2027, we expect to see the first truly general-purpose multimodal AI systems capable of learning new tasks through demonstration rather than explicit programming. These systems will watch humans perform complex activities and develop their own understanding of the underlying procedures. By 2030, the integration of multimodal AI with advanced robotics will produce the first generation of general-purpose robotic assistants. These won't be limited to specific tasks like current industrial robots. They'll be capable of operating in human environments, understanding natural language instructions, and adapting to novel situations through real-time learning. The period from 2030 to 2035 will likely see the emergence of what researchers are calling ambient intelligence. AI systems so thoroughly integrated into our physical environment that the boundary between digital and physical experience begins to dissolve. Smart cities will respond to human needs in real time. Buildings will adapt their configurations based on occupant behavior and preferences. Transportation systems will coordinate seamlessly with human intent rather than rigid schedules. By 2040, we anticipate AI systems that can engage in collaborative creative work with humans across all domains: scientific research, artistic creation, engineering design, and philosophical inquiry. These systems won't just process information or execute tasks. They'll contribute genuine insights, generate novel solutions, and participate as creative partners in human endeavors. The creative industries are already beginning to grapple with these possibilities. Musicians are experimenting with AI that can understand not just musical theory, but emotional context, cultural references, and aesthetic intentions. Visual artists are working with systems that can interpret conceptual briefs and translate them into sophisticated visual narratives. Writers are collaborating with AI that understands narrative structure, character development, and thematic resonance. But this transformation extends far beyond individual applications. We're approaching a fundamental shift in how human societies organize and operate. The economic implications alone are unprecedented. McKinsey's latest analysis suggests that multimodal AI could automate not just routine tasks, but complex cognitive work that requires understanding context, interpreting ambiguous information, and making decisions based on incomplete data. The legal profession, medical diagnosis, financial analysis, scientific research, creative production, virtually every field that requires sophisticated reasoning about complex, multifaceted information will be transformed. This doesn't necessarily mean human displacement, but it does mean fundamental changes in how human expertise is applied and valued. Consider the implications for governance and decision-making. Multimodal AI systems capable of processing vast amounts of social, economic, and environmental data simultaneously could assist in policy development with unprecedented sophistication. They could model the complex interactions between policy decisions and social outcomes, helping human leaders understand the potential consequences of different approaches. However, this transformation brings profound challenges that we must address proactively. The concentration of multimodal AI capabilities in the hands of a few large technology companies raises serious questions about democratic governance and individual autonomy. If these systems become integral to daily life, who controls their development and deployment becomes a fundamental question of political power. Privacy concerns become more acute when AI systems can observe, analyze, and remember human behavior across multiple sensory modalities. Current privacy frameworks are inadequate for a world where AI systems can infer emotional states, health conditions, and personal preferences from subtle behavioral cues that humans might not even notice. The potential for manipulation and control through multimodal AI is unprecedented. Systems that understand human psychology at this level could influence behavior in ways that bypass conscious awareness. The development of ethical frameworks and regulatory structures adequate to this challenge is one of the most urgent tasks facing global society. There's also the question of human agency and skill preservation. As AI systems become capable of handling increasingly sophisticated tasks, how do we ensure that humans maintain the capabilities necessary for independent thought and action? The risk isn't just technological dependence, but the atrophy of human capacities that might prove essential in contexts where AI systems are unavailable or unreliable. The labor market implications require careful consideration. While multimodal AI will create new opportunities in industries, it will also eliminate entire categories of work. The transition period could be socially destabilizing unless we develop new models for education, career development, and economic security that account for rapid technological change. International cooperation becomes critical as these technologies develop. The potential for multimodal AI to provide military and economic advantages means that nations face powerful incentives to prioritize capability development over safety considerations. The need for international frameworks governing AI development and deployment becomes more urgent as the technology becomes more powerful. Yet despite these challenges, the potential benefits of multimodal AI are too significant to ignore. The ability to accelerate scientific discovery, improve medical outcomes, enhance educational opportunities, and augment human creativity could address some of humanity's most pressing challenges. Climate change, disease, poverty, and social inequality all present complex, multifaceted problems that could benefit from AI systems capable of sophisticated, multimodal reasoning. The key is ensuring that this technological revolution serves human flourishing rather than undermining it. This requires unprecedented collaboration between technologists, policymakers, ethicists, and civil society. We need new institutions capable of governing technological development at the pace of innovation. We need new educational approaches that prepare humans for partnership with AI rather than competition against it. The research community is increasingly recognizing these responsibilities. Yann LeCun at Meta emphasizes that the next revolution will come when AI systems can learn as efficiently as humans do, but he also stresses the importance of developing AI that enhances rather than replaces human intelligence. Demis Hassabis at DeepMind argues that AI development must be guided by consideration of long-term consequences, not just technical capabilities. Stuart Russell at Berkeley has been particularly eloquent about the need for AI systems designed to be compatible with human values and preferences. His work on cooperative AI suggests approaches to ensuring that advanced AI systems remain aligned with human interests, even as they become more capable. As we look toward 2040, the trajectory seems clear. Multimodal AI will become as fundamental to human civilization as electricity or the internet. The question isn't whether this transformation will occur, but how we'll shape it. The decisions we make in the next few years about AI development priorities, regulatory frameworks, and social adaptation will determine whether this revolution enhances human potential or undermines it. The convergence of multimodal AI, robotics, brain-computer interfaces, and quantum computing represents a technological inflection point comparable to the agricultural or industrial revolutions. But unlike those earlier transformations, which unfolded over centuries or decades, this change will happen within a single generation. We have the opportunity to be intentional about this transformation in ways that weren't possible during earlier technological revolutions. We can anticipate challenges, develop mitigation strategies, and design systems that promote human welfare from the outset. But this requires unprecedented foresight, cooperation, and wisdom. The multimodal AI revolution is not just about technology. It's about the future of human consciousness, creativity, and agency in a world where the boundary between natural and artificial intelligence becomes increasingly fluid. How we navigate this transition will define the trajectory of human civilization for generations to come. The future is not predetermined. The choices we make today about how to develop, deploy, and govern multimodal AI will shape whether this revolution leads to human flourishing or disruption. We have the opportunity to create AI systems that amplify the best of human intelligence while addressing our greatest challenges. Whether we seize that opportunity depends on our wisdom, cooperation, and commitment to ensuring that technological progress serves all of humanity. This is the future we're building. This is the challenge we must meet. And this is why understanding the multimodal AI revolution isn't just a technological imperative. It's a human one. Thank you for joining me on Future Unveiled. The future is not something that happens to us. It's something we create together, with awareness, intention, and hope.